So what I'm going to do is I'm going to provide a quick introduction of our technology arena we call big memory computing and what our company MemVerge is doing in that space. Let's start with what's happening from the 100,000 foot view. And what's happening is memory, data, and AI are intertwined in the evolution of the modern generation of memory infrastructure that started in 1969 with the invention of DRAM. Now, for the next 50 years, up until the introduction of Intel Optane persistent memory, the user experience for memory infrastructure has remained the same. It's expensive, it's volatile, it's scarce, and it's non-composable. Now, the usage of DRAM infrastructure has evolved. So around the turn of the millennium, fast data emerged. To us, that's data that needs to be processed instantly by ATM, e-commerce, ticket reservation systems, which led to the development of in-memory computing, where an entire application state can reside in memory, but up until today, it's dependent on DRAM, which means it's difficult to scale because it's expensive and it's very limited in its capacity. Around the same time frame, 2010, commercial AI apps also emerged. They use fast data, they use in-memory computing, applications like fraud detection, retail recommendation engines, and social media profiling, the evolutionary step during the early 2000s. Now what's happened is revolutionary. Big memory computing, where finally, after 50 years, the user experience can change. It's being driven by big and fast data. That's big data, massive data sets that are too big for in-memory computing, fast data that's too fast for storage I/O. There's three new building blocks. First is Intel Optane persistent memory. It brings lower cost memory. It brings higher capacity memory. It brings persistence. The second is MemVerge Memory Machine software. We can take a mix of DRAM and persistent memory and virtualize them into a composable pool of software-defined memory. And then in just another year or two, CXL is going to come onto the scene. So that's bringing a open architecture for memory. It's bringing a petascale fabric with heterogeneous processors, heterogeneous memory. And at that point, memory infrastructure is now on its way to becoming something vastly different, affordable, persistent, abundant, composable. And we think that that's going to be important, and it's going to be key to AI reaching its potential, which is going to be ubiquitous in all applications. We also think through our analysis that perhaps AI field day is going to have to be folded into tech field day because it's going to be ubiquitous. So big memory computing, what is it? Well, what it does is basically eliminates I/O. So big data is now fetched from performance storage, now runs in memory. So this is a simple diagram of the old von Neumann model, where data is fetched from performance storage, which is an order of magnitude slower. And for applications that need to process big and fast data, that can kill performance. So what big memory does is it transforms that in performance storage into one tier of software-defined memory with unlimited capacity, especially when CXL comes about. You can deploy tiers of memory for optimum cost and performance, all with nanosecond performance, granular data management, all without any changes to your applications. So that brings us to MemVerge. So the company is led by the creators of vSAN and Extreme IO, which is now the Dell all-flash array line. They're also both now the current market share leaders in HCI software and all-flash arrays, and product lines with billions of dollars in annual revenue. And what we're doing today now is pioneering big memory computing, where we can simultaneously process huge data sets, deliver real-time results, and transform the memory tier into an H8 tier. And the company is backed by a blue chip list of investors, as you can see below. This is our product. Our product is called Memory Machine. It's enterprise class memory virtualization software. On the bottom white box, you see the transparent memory service. This is what virtualizes the pool of heterogeneous memory, provides the DRAM-like performance, and does it without any changes to your applications. And then above, you see the enterprise class data services. And what that is just think of all the services that you have with storage today, your ability to provision, performance, capacity, quality of service, security, et cetera. All those are now going to be made possible through our snapshot capabilities, which enable those type of in-memory services. So since we've introduced Memory Machine in September of last year, we've already learned with our customers that we can bring a lot of value in the database arena, where we can provide the same cost with double the performance for in-memory applications. We can drive higher availability in terms of hot restarts. We've proven with some customers that we can retire an entire cluster in a matter of seconds. And IT organizations are using our snapshots to increase their productivity by tiering the memory, creating sandboxes with our thin clones, and with fleet management capabilities. We've also proven that we can dramatically improve multi-stage analytic pipelines, ML pipelines. So the old model was repetitively loading data from storage, which can take a long, yes?
Could you talk a little bit about the fleet management services? I'm just trying to figure out how that plays out in memory.
Well, simply put, we now provide the ability to visualize where your whole fleet of servers, you can visualize the memory through one console and the activity about your memory across all the servers. So that allows, once you can have that visibility and you have the tools to manage, to move the memory, to tier the memory, replicate the memory, you now have the ability to do that on across a fleet.
When you talk about moving the memory, you're talking about composability kinds of things?
I think it can be mobility, it could be composability in terms of quality of service, in terms of isolating applications memory. It could be moving data from one tier to another. That makes sense?
Yeah. I'm just trying to. I understand the data, but I don't understand the memory moving around without physically plugging and unplugging cards and stuff like that. But the composability might play out there somehow.
Yep. Yue, did you want to add anything?
Yeah, so basically we can, by moving the memory, so essentially it's based on our snapshot feature, which I will cover in the next. So essentially you can move the snapshot, you can take a snapshot of your memory and move the snapshot to other machines, so replicate to other machines, then you can basically restore the snapshot.
Yeah, I completely understand that you move the data. So you move the data that's sitting in memory, but I don't see how you can move the memory from one machine to another without physically moving it or using some sort of composability layer on top of it.
I think we're talking about the data, not the memory.
Yeah, great. I'm good then. Thanks.
Yeah, so for ML and multi-stage analytic pipelines, as I was saying, the current methodology would be repetitively loading data at each stage, and the larger the data set, the longer it takes, and then executing at each stage with I/O to storage. And what we found is that by enabling big memory, that we can dramatically reduce the throughput for these pipelines. And in one customer, we have evidence that we were able to shave 60% off of their pipeline throughput. For cloud users, VM density is money. And the situation there is for memory-bound applications, the way they solve the problem is they deploy more servers and distribute the memory. With big memory, they're able to have higher VM density enjoy server consolidation, lower space, lower power, lower cooling, in addition to some of these advanced in-memory cloud services, of which we touched on a second ago with Ray, more composability, more mobility, et cetera. So this is my last slide. Go ahead.
Might be a stupid question, but when you talk about the cloud infrastructure and how people can get benefits with your stuff, are you talking about the cloud vendor or the people hosting the infrastructure on the cloud platform?
I think it could be both. I think for a cloud infrastructure vendor, their profitability is based on VM density. But I think we're finding we have enterprise customers today that also want to consolidate servers that can benefit from server consolidation. Everybody wants that. So this is my last slide, and where we're at today, both vendors and customers, is we're at an inflection point, which Andy Grove defines as there's a 10x change in an element of business. What worked before doesn't work now. This inflection point is defined by the emergence, and it's happening really fast, of big and fast data. So if you're an end user or you're an application vendor that is dealing with big and fast data, we expect that, based on Andy's definition, that if you adopt big memory computing architecture, you're going to go on to new heights. While if you're having to deal with big and fast data with the old model, that you're destined to decline.
Frank, this is probably a softball question, but what is your big advantage over, let's say, an application that is using application direct mode with Intel Optane?
I would say that we pick off. Well, first of all, you don't need any app. You don't have to integrate App Direct. So
that's not my question. If they already have, or they've gone through the process, what would be your advantage?
I would say it starts off with our enterprise class data services. So as far as I know, we're the only source for snapshot technology, which enables enables you to manage your memory tier like you do your storage tier.
Mm-hmm. Another feature is that we allow user to configure a different DRAM PMAM ratio for different process. So that's not possible with the memory mode or Intel's Optane's memory mode.
I wasn't asking about memory mode, application direct mode, but I see your point.
Mm-hmm. App direct mode basically requires user to actually change their app to use it as memory. So we don't.
Yeah, from my point of view, your big advantage are the enterprise services that Frank brought up in the snapshotting.
That's right.